You can, yeah, I think you can share my screen as well so that side by side you can. If you can pull in my screen also, I think I've shared it. So you can be side by side.
Hey everyone, thank you for joining our webinar today. We are just waiting for a few minutes to the people to join in. Let's give it a minute. All right, so it's 6:32 now. Let's start. So thank you everyone for joining the AWS User Group Vizag June 2021's webinar. The topic for today is AWS Databases 101, and we have Faizal Khan who will be speaking about this topic, and he's a corporate trainer. He has a vast amount of experience behind him, and he's also the organizer of AWS User Group Hyderabad. We are very much thankful to Faisal for giving us an opportunity to host his session today. So without much this thing, I'll have Faisal come on the screen. Faisal, you're on mute.
Sorry about that. Hello, everyone. And hello, Srika. Thank you for pulling me in. I think you could go ahead and share my screen as well. So could you pull up my screen, Srika? Yep. All right, everyone. Thank you for joining in. Wonderful to have you here. So this is our AWS User Group Vizag webinar. And as you know, this is the AWS Databases 101. So we'll be covering we'll be starting from some basics of what databases are and what are the different database services that we have on AWS. So to give you a quick introduction about myself, my name is Faizal Khan. I'm the founder and CEO of a company called Ecom India Cloud IT. We're basically a digital transformation company. We help organizations move on to the AWS cloud. We do a lot of optimizations on the AWS cloud as well. Personally, I come with about 16 plus years of experience in the infrastructure management side. Seeker, I think my screen. Yeah, thank you. So I come with about 16 plus years of experience in IT infrastructure management, and all of this has previously with organizations like JP Morgan Chase, Bank of America, Dell, and ITC. I'm also a certified solutions architect, associate level. I'm also part of the AWS Community Builders program, which is kind of a program that helps people like us do more webinars like this, reach out to more users to bring them into the AWS ecosystem. I'm also the lead for the AWS Hyderabad user group as well. My contact details are at the bottom, which I'll be sharing also once the session is over. So let's get started. We'll look at what are the things that we're going to cover today. We are going to look at the different type of databases and the use cases for these databases. We're going to look at all of the AWS database services that are on offer. We'll look at some of the questions that come up when we talk about whether we should use an SQL type of a database or a NoSQL or something like that. And then we'll jump into the core AWS database services, which is basically RDS or Relational Database Services. And we'll talk about the different database engines that are available within RDS. We'll also look at something with regards to high availability, like how do you set up a database in order to get good availability, whether you can set up a single database or multi-database kind of setup. We'll look at some of the other database options, which is Aurora, which is an AWS database service. And then post that, we'll look at some additional options that you have when you use the AWS database services when it comes to things like serverless, proxy, caching, etc. After that, we look at the options of backing up your databases and also the option of migrating your databases from an existing something like your existing in-house database that you want to migrate into AWS. All right. So let's talk about the different types of databases or different types of use cases and how do you pick a database type. So there are many different database types. Now, these are what I've listed is some of the very common ones. So the most frequently used ones is what you've listed. There are many other types as well. Primary, what the world has been using for a very long time is relational databases. Let me just quickly list out all of the databases. So there are relational databases, there are key value store databases, there are document databases, in-memory databases, graph databases, time series, and ledger databases. So we're just specifically talking about what these databases do and how do you decide what kind of a use case you have. If you look at specifically for relational databases, we're talking about databases which have things like relational tables. You have tables which have columns, which have the data in them. This is the most commonly used database type that you're going to come across. It is easy to get started. Easy to set up. If you don't know yet what are the things that you would need in your application, it's a very easy option to start out with relational databases. All of your existing ones like your MySQL, Oracle, SQL, all of this fall under the relational database type. One thing to keep in mind is that when you talk about relational databases, it's more or less like SQL, structured query language. So all of your queries are going to have a particular language structure when you're querying them. You're going to have all of the data in your tables. You're going to infer relationships between those tables, etc. when you put your data. There is something called ACID, which is it's talking about the data integrity and your data durability, your data issues that you might encounter when you do things like transactional data. For example, like when you do a banking transaction, everything in that transaction has to happen at one go, right? And as in all of those transactions should happen or none of them should happen. If one transaction fails in that, it's supposed to reverse itself, etc. Right? So that's something with regards to ACID, which we'll kind of cover later. You're going to use this in your ERP systems, in your CRM systems, your any kind of the financial systems that you have. You're most likely going to see these kind of databases. Let's move on to key value store. This is kind of like a high throughput, low latency database system, which can scale very much better than how you would normally scale relational databases. And I'll talk about this when we discuss the point about SQL versus NoSQL. You're talking about applications that are built today, mobile applications, etc. You're going to see a lot of them that are built on the key value store system. And let's talk about document databases. In this, your data is stored in kind of document format where all of your data regarding a particular entity is stored in one JSON document, so to speak. Like right? You could have different data formats, but mostly you're going to see your documents stored in one particular file. Of course, you're going to have uh, for one entity, you're going to have one file. For another entity, you're going to have another file. So you will have all of your data in multiple files or documents, so to speak. This also we'll discuss when we talk about SQL versus NoSQL. Then you have your in-memory databases. These are databases that are actually running on your RAM, on your system memory, and not on the disk. This is very useful when you're looking for caching or when you want microsecond latency when you want to pull out your data, because whenever you query something, it takes some time for, if your database is stored on the disk, it takes some time for the data to be pulled out from your disk, right? Unlike memory, which is the data is always, like, the memory is the fastest component in your system, right? So anything that you store and retrieve from that is going to be super fast. There are certain limitations because obviously it depends on the size of your memory. You can't have terabytes and terabytes. I mean, you can have memory that much, but it's going to become very expensive, right? So you wouldn't use this for putting all your databases. You wouldn't use in memory for all your database types, but more or less, like, if you have small data sets, like, you're doing some leaderboards, or you're doing some real-time analytics where you need to quickly pull some data, a defined set of data, uh, you could use this in-memory option. We'll talk about what each of these databases are offered in AWS. We'll talk about that. Then you have your graph databases. The easiest way I could put this is your Facebook, right? So when you have multi relations, for example, you have friends who have other friends, and when you want to see the status of your friends, or you start seeing status from friends of friends, etc., this is kind of where graph databases come in. None of the other databases have that kind of relationship that you can pull out from multiple points of data. I mean, you could do it with relational databases, but the amount of queries that you have to do and the time it will take to pull that data out will be much higher compared to something like a graph database. Then you have your time series databases. These are used mostly for, if you have heard about IoT, where you have a lot of data that's coming in over a period of time. You're not going to use this for querying data. This is mostly used for collecting and storing data, right? For example, weather data. So if you want to store weather data over a period of time, you could use these time series databases, because you're not doing a lot of querying necessarily. You're storing it as a time value, time series data over a longer period of time. And then you have ledger databases. The easiest way I could put this is in one word: blockchain, right? So you're talking about immutable databases where once it's written, that's it. You can't modify it. And that's kind of the concept of blockchain. So this is essentially kind of a blockchain type of database, right? So let's move on and let's look at what are the different database types that are available within AWS. Srikar, is my camera gone?
No, I
All right.
was just making the presentation,
All right. All
the
right.
main screen.
No problem. All right. So when you have purpose-built databases on AWS, so we discussed what all of these different types of databases do. So let's see what are the different types of databases that you get on AWS for each of these. So first you have the relational database, under which you have Amazon Aurora and Amazon RDS, right? Now, under RDS is where you have most of your existing database types, things like MySQL, Postgres, MariaDB, Oracle, and SQL Server. We'll today be focusing on the relational database types within AWS, and we'll discuss in depth the RDS side of things. Under the key value store, you have the option of going with DynamoDB. Under document, you essentially have DocumentDB. Think of this as the alternate for MongoDB. Under in-memory, AWS offers a service called Elasticache. Now, Elasticache in itself is not a database, but it offers you multiple in-memory database options, things like Redis and Memcached, which are basically in-memory databases. Under graph database, you have AWS Neptune. Under time series database, you have AWS or Amazon Time Stream. And under the ledger database, you have the AWS Quantum database. So we'll look at in depth today under the RDS section. So before we go deep down into RDS, let's quickly look at the question of SQL versus NoSQL. So when I say NoSQL, I'm not saying no SQL at all. This is basically saying not only SQL, right? So you have SQL and you have not only SQL. So under SQL, you have a predefined schema. So you decide beforehand what kind of a schema that you're going to be working with. And you're going to define that schema structure, and then you're going to put your data into that. And also, for example, if you defined a particular column as integer, right? You can only put integer values in that column. You cannot put any other values in that column. So that's one of the things with SQL. Unlike with NoSQL, the schema is a little bit dynamic, so you can literally put data in any format that you like. Of course, you have to decide beforehand how you're going to pull out all of this data. That is something that you will have to decide beforehand with NoSQL. But when you put in your data, there is no limitations as such. That a certain type of data only fits into a certain column or anything like that. The schema is very dynamic. In SQL, you have your relational tables, which is you have your data in different tables, and their relationship to each other is defined by using the keys. So you use the primary key to query data or join data from different locations. When you talk about NoSQL, you have different types of data. You store the data in key value pairs. For example, you have X, Y. You might store the key as name and the value as the actual name, right? So that is a key value store. And like I told before, you have the option of storing your data inside documents, like complete JSON documents. So everything about your particular data will be in that particular document. And of course, you have graph, which is like the Facebook types. With SQL, you have a structured query language, and if you need to pull out data from multiple tables, you have to do joins, right? So if you want to pull out data from 4 tables, so that you can have the entire data about a particular customer pulled out, for example, a shopping cart information. Like when you pull out the data regarding the shopping cart, you have to pull out the customer name, the order ID, the items inside that cart. So all of these are not stored in one table. So you have to query multiple tables, and you have to join all of those queries together and pull out the data, which could take some time. And depending on how many joins you have, it could get really complicated. With NoSQL, the queries are quite dynamic and they're not standard per se. So you can literally query just the data that you need without actually needing joins. It's not that you can't do joins, you can do joins, but you wouldn't necessarily come across that as much as you would come across in your SQL database types. Like I talked before, ACID compliant by default SQL databases. This is kind of like on the atomic level, every transaction is 100% verified, right, or complete, in the sense that when you withdraw some money from your account, the action of deducting that amount from your account, making a log of that, and if you were to transfer that money to someone else, putting the money into their account and then updating their balance and updating your balance, all of this is like one single transaction. Of course, multiple actions are happening in that, but it's one single transaction. And SQL databases kind of guarantee that always that happens. And if at all there's an error in one of those actions, the entire action will be rolled back. You have that option with ACID compliance. When you're talking about NoSQL, there is limited ACID compliance in the sense that if you're talking about updating a single record, you could kind of have ACID compliance. But when you're updating multiple records at the same time, you will come across issues with regards to ACID compliance. Now, this is not an undoable thing on NoSQL. You can do it, but it requires some additional configuration from your side. SQL databases are more vertically scaling compared to horizontal. Now, when I talk about vertical and horizontal scaling here, just remember here that It's not that SQL can't scale horizontally. You could, but the effort is much more. And it's also not that NoSQL cannot scale vertically. It could, but the effort is different. Vertical scaling means where you're adding more CPU and RAM to your existing database. So, for example, if you reach a particular limitation, you need to add more, make your database a little bit more faster, or add more RAM, add more CPU. You would basically do that as vertical scaling. When it comes to horizontal scaling, you are increasing the number of servers. So instead of one server and adding more RAM to it and adding more CPU to it, you are having multiple servers, right? So instead of one database server, you're going to split up your data across multiple databases. This is kind of the difference between NoSQL and SQL. So before I go forward, I just want to quickly ask if there are any questions with regards to the database types that we have talked about, and any questions with regard to SQL and NoSQL. All right. Doesn't look like any questions. I don't see anything.
Yep, no questions so far. We're good.
All right. Okay, so let's move on to.
So one
sorry, did you
question
say
is
something?
there.
Yeah.
So one question is, how are we going to read the data stored in the document with JSON format?
So it's just like pulling any other JSON data, right? So it's not an SQL language. Like, you're not going to do select star from like you would do with normal databases. It's just your just like how you would pull any JSON data, right? Towards the end, I think I'll probably pull up an example for you so that you can understand a little bit better on that. But just remember, it is not your select star kind of data. Okay, just remember that.
Thank you.
All right, let's move on to RDS, or Relational Database Services. All right. Relational Database Services, or RDS, is AWS managed databases. So anything under the relational type of database, AWS offers you an option, which is a completely managed database, which basically means you don't need to worry about managing the actual server that the database is running on. What that means is that you don't need to worry about updating the server. All of this, like updating, patching the server, etc., is kind of done by AWS themselves, right? So you don't need to worry about doing that. AWS takes care of that. Even actually updating the database version, AWS can do it automatically for you. If you kind of select auto upgrade database version, even the database version can be upgraded by AWS. So all of the actual management task or administration task of the actual database server is taken away from, not taken away from you, they're doing it for you, right? So you don't have to worry about that. However, what you are going to manage is you're going to manage the actual use of the DB, pulling the data out, managing how the data is stored in it is kind of what you're going to do. It's completely resizable, which means you can have a small database, you can have a large database, you can scale up and down depending on what your actual requirement is. Like I already said, AWS kind of already handles the time-consuming tasks in terms of setting up the server, patching the server, etc. is completely handled by AWS. You have multiple engine types that are available, which I'll discuss in the next screen. High durability options. This is where you decide whether you want a single server or you want multiple servers, which also I will kind of discuss in the upcoming screens. Like I already said, it does automatic patching and also automatic backups for you if you configure the backups. I will be talking about how to set up the backups and how to configure it a little bit later on. You also have the option of encrypting the connections between your database and your applications using SSL, which is kind of done through something called KMS within AWS. Let's talk about the different types of engines that you're going to find within RDS. So you have multiple types of engines, like on the commercial side, on the open source side, as well as a cloud native. On the commercial side, you have good old Oracle databases, and you also have Microsoft SQL servers. On the open source side, you have MySQL, you have MariaDB, and you have Postgres. And on cloud native side, AWS has their own database that they custom built for the cloud, which is known as Amazon Aurora. Amazon Aurora, as of today, it supports MySQL as well as Postgres. So Aurora in itself is not a database type. It's a cloud native database which supports MySQL and Postgres. So if you're already using MySQL on the open source side and you're not using Aurora, you can kind of migrate into AWS to use Aurora. Of course, you can use AWS RDS MySQL without using Aurora as well, okay, which we will talk about. Now, before I go ahead and talk to you about the concept of high availability and multi-database and all of that, I just want to quickly, kind of refresh what regions and availability zones are. So regions, as we know, are different locations where AWS has their data centers. So you have many regions spread across the world. The last I checked, I think it was about 21 or 26. I keep forgetting the number. There are multiple regions that we have with AWS. Now, each of these regions have something called availability zone in them, right? An availability zone is a separated zone of data centers. So in availability zone 1, you're going to have multiple data centers. In availability zone 2, you're going to have multiple data centers. In availability zone 3, you're going to have multiple data centers. And they're all physically separated by some distance, some meaningful distance, so that if something happens to one availability zone, it doesn't affect the other availability zone. And when you're launching your servers, whether that be your web server or whether that be your database servers, you're basically going to be launching them into different availability zones. One thing to keep in mind, just because you launch something in one availability zone does not mean that by default it's going to be automatically copied across other availability zones. No, this is a conscious choice that you're making, whether you want to have your systems only in one availability zone or whether you want to have it in 2 or whether you want to have it in 3. That is a choice that you're making, and you actually pay extra depending on how many availability zones you use. So just a clarification on that concept before I go into database high availability. So let's talk about availability for databases, RDS availability. So you have the cloud, AWS cloud, within which you have your regions and you have the availability zones. Now there is the concept of VPCs and subnets. But for right now, I'm going to remove this VPC from the screen so that there's no confusion here. But just understand that there is also something called VPC inside which you have subnets, etc. But just to keep things a little simple right now, we're going to talk about the availability zone inside which you have your database server. So in this case, this is a minimal deployment where you're talking about a single database that you're running. So you're just running one single database server. The issues that you're going to come across is obviously the problem with what happens if something happens to this particular database, because you only have one, right? So if anything happens to this database, obviously your application will stop working. There could be a chance of loss of data. And if you're not able to recover this, then you're in bigger trouble. And if you don't have backups, then you're definitely in trouble, right? So having a single availability zone, single deployment, it will work. You can still run your application, but then you're at very high risk because if anything happens here, you're going to have issues. And also the fact that, let's say, even if you want to upgrade, you want to scale vertically, you want to increase the size of your database, right? For example, let's say you had a server with 2 CPUs and 4 gigs of RAM. But now you're having more data to store and you need a more powerful server. And let's say now you need to upgrade to 4 CPUs and 8 gigs of RAM, right? So in that case, upgrade is also going to give you interruptions because there is only one server, right? So you can't directly upgrade it on the fly. You have to kind of stop it and then kind of upgrade it and then start it back up. So there is kind of an interruption that happens there. Unless, of course, you are taking a copy of this and then you're creating a new one and then you're connecting to that, you could do that. But then again, there will be some data you have to kind of copy over once that is up. So this is not an ideal solution. This is where we bring in the high availability or multi-AZ solution for RDS. Now, this is the same thing again within the AWS cloud. You have a region, and again, there are multiple availability zones that we're using here. And remember, there is a VPC, but then I'm just going to take out the VPC for a second. So you have multiple availability zones, and you're going to place your databases inside those availability zones. And in this case, you're going to have a master database and you're going to have a standby database. Both of them are not going to be used at the same time. You are primarily going to be connecting to the master, and then as you are using it, all of the data kind of gets replicated across to the standby as well. Now, in case something happens with the master, AWS has the option of automatically switching it over for you to the standby. So they will automatically switch it over for you. I have seen this working within about 30 seconds. So if there's a failure of the master in about 30-second time frame, it actually switches over to the standby. This also allows you to upgrade your databases without any interruption. For example, let's say you're continuing to use your master. You can upgrade your standby to a larger size first, and then you can switch your traffic to the standby, and then you can upgrade your master, right? So you can actually upgrade or scale up your systems without any interruption, because you can always switch back and forth as you're upgrading any systems over here. All right. Before I go into Aurora, any questions on the high availability concept for RDS, whether we set up multi AZ or a single AZ? I'll stop for a quick second.
It's like we don't have any questions as of now. That's good.
Right. I guess there's also a slight delay in the stream, right? So they probably didn't yet hear my question. But anyways, I think I don't see any questions so far. So, all right, let's move forward. I will come back to the concepts of backups, of read replicas, etc. for RDS. But before I do that, let's quickly discuss the concept of Aurora. Okay. Now, before I actually go into Aurora itself, remember here, when you are talking about RDS, standard RDS, you are talking about instance-based servers. So this is one instance, or this is like one server, right? And this is another server. So this is like one, you can think of it like an EC2 plus a database, right? That's kind of what it is. So this is like one server and this is another server. So you're talking about single unit items, single compute items, right? But when we move to Aurora, things change a little bit differently, because over here, each database has its own disk, right? So this one database, this master database, will have its own disk that is attached to it, kind of like your EBS volumes. Then this standby also has its own database, its own disk attached to it. And the data in this both are not necessarily the same at all times, because there might be some replication lag of a couple of seconds or something like that. So data here, until it replicates over to here, you might not necessarily have the same data across both the instances. So just keep that in mind when we're talking about RDS per se. Now, when we move to Aurora, the whole architecture is a little bit different. We are talking about cloud native relational database engines. So this is a database type that was built for the cloud, on the cloud by AWS. This is MySQL and Postgres compatible. So if you have a database that is already MySQL or Postgres, you can kind of bring your database into Aurora. And of course, you can also just start a new database that is either MySQL or Postgres inside Aurora. It supports up to 128 tebibytes, which is, you can think of it like terabytes itself. It's just a conversion value difference. And something called up to 15 read replicas, which I will talk about in a second. This goes beyond what RDS does. So in RDS, remember I told you that you don't have to manage the actual server, you don't have to worry about patching the server, you don't have to worry about updating the server, but you still had to take care of the actual processes running on the server, and you still had to manage how your data is handled by RDS itself, right? Aurora goes one step further. It automatically looks after any failing database nodes, and it will automatically bring up a new database in case one of the node fails. Also, any processes that are failing within the database on the database application level, it will automatically recycle those processes as well for you. So as a DBA, you really don't need to like go in and kind of restart them manually or anything like that. It will kind of do even that for you. And even if there is a master database failure, it immediately promotes one of the other standbys or other replicas to master. Remember, before I told you, when we do the high availability for RDS, we did have a standby and a master. So when the master failed, it switched over to the standby, and basically the standby became the master, right? um, but the master was still kind of there, it was still lingering around. But in this, it kind of completely takes over as the master, and that becomes the new master going forward. There is an option of serverless and Aurora Global Database. Think of Aurora Serverless as not having to worry about actual number of actual number of databases. In the sense, you no longer have to worry about CPU and memory, right? Because here also, when you talk about nodes, you are still talking about compute units or single servers. For example, a server with two CPUs and 4 gigs of RAM, right? You're still talking about that when you talk about actual nodes, right? But when you talk about serverless, it completely removes the concept of having X number of servers, or having uh, this much CPU and this much memory. It just basically handles your database. Think of it like that. You don't have to worry about the underlying server that is looking after your database, because there is not a single server, there are multiple servers, and it's kind of doing it in a serverless fashion for you. The global database option will make more sense once I kind of talk about read replicas. But essentially, the global option is where you're having a copy of your database as a read replica across a different region. So we talked about the regions and availability zones, right? So you might have, let me just quickly bring that up. So you might have your database in one availability zone normally, but when you talk about global databases, you basically have one in this region in this availability zone, and then you have another one in another region in another availability zone. But all of them are kind of talking to each other at the same time, right? Okay. So we'll talk more about that when we talk about read replicas. Now, Aurora is different, I told you, in the sense that when you talk about general RDS servers, you have each of them have their own disk, right? But here you have something called a shared volume. So if you have one master Aurora server and you have two replicas, essentially they are all kind of reading from the same disk, so to speak, right? This is why you don't need to worry about replicating your data across multiple nodes, unlike in RDS, where I told you that each of them have their own hard disk and you kind of have to wait for the data replication to catch up, right? Over here, that's not the case. You have your data that is split across multiple availability zones, and all of them share the data on the same layer, so to speak, right? You're not having different hard disks for different nodes within Aurora. So that's one of the main difference when you talk about RDS, normal RDS, and Aurora. Okay, let's talk about some of the other options that you have. Read replicas. This is important if you have customers across the globe. Even if you want to increase the speed of your data access, or you want to reduce congestion in your database, you can think of using read replicas. The concept here is that you have one master database and you have multiple read replicas. The idea here is that all of the writing will happen to your master database, and all of the reading will take place from your read replicas. I mean, you can also read from your master, but your master's primary job is to write the data, and then it's replicated across to the read replicas, and people can read from the read replicas. The idea here is that if you have read replicas that are placed across different regions, you are essentially bringing your data closer to your customers. So if someone in Europe wants to access your services, when they are opening up the site or when they're opening up your application, it doesn't have to go all the way to US where your master database is. It can read the data directly from your replica that you've placed in the Europe region, right? So this is one way to increase access speed for customers. Another reason is you can reduce the load on your database. For example, you don't want everyone to read from the single database, because then thousands and thousands of users will be reading from a single server that you have, right? And that's obviously going to create a lot of congestion. Now when you split out this into read replicas, some people will be reading from this server, some people will be reading from this server. So some customers, you're splitting up your customer load across multiple databases in this case. Okay, I keep forgetting that. All right, so that's the concept of read replicas. If you want to reduce the load on your main server, if you want to bring data closer to your customers, and also remember, your read replicas can also act as a standby, right? So in case for some reason, if your master fails, you can always turn one of these read replicas into your master. So you can also maintain availability of your databases. There is a new option called RDS Proxy. I mean, it's not new, but relatively new, just a couple of years old. RDS Proxy actually helps you in reducing the number of connections that are going into your databases. So depending on how many application servers you have, whenever it wants to read something from the database, generally speaking, it has to make a connection to the database, and the database has to open a new connection for that application and then transfer the data, right? And every time it does that, it takes the server is wasting resources opening and closing connections, right? And sometimes the connection is only open for a certain amount of time, and so when the same application server comes back and tries to read new data, again it has to open a new connection. This is kind of where the proxy comes in, where RDS is essentially creating a layer in front of your databases. All of your application servers will talk to the RDS proxy, and the proxy will keep, 1, 2, 3, maybe 4 connections open. It'll basically pool all of the connections. So rather than opening individual connection for each application server, it will try to use the existing connections it has already open, right? So there might be certain number of connections that are already open between the proxy and RDS, and it will kind of try to use that for the application servers. So this will kind of help you reduce the load on your RDS as well. And also the fact that RDS proxy actually has a faster failover time, because it's not your application that is talking to RDS now directly, it is the RDS proxy talking to RDS. So if it fails for some reason, for example, if it is switching to a standby, RDS proxy can immediately switch to a standby. So if you had a 30-second failover before, you could see less than 15 seconds or less than 10 seconds failover now happening with RDS proxy. And also the fact that RDS can actually ask your connections to wait while it switches over, right, to your standby. It can do that as well. So this will basically not drop the connections that are coming from your existing application servers. Unlike when you do a manual switchover, or when normally the switchover happens, sometimes the connection fails because of that. All right, let's talk about backups. Now, before I do that, I think we have a couple of questions. Srikar, do we have any questions?
Yes. So we have a question from Crap Milton. So he said he's asking, so in AZ2, the DB is not a primary for others.
I think he's talking about these read replicas, if I'm not mistaken. Right.
Yes.
So for the applications that are in this region, for example, okay, if he's actually referring to the read replicas here, if your application in Europe, you can actually have two set of databases. You can have a database into which your application writes, and you can have a database into which from which your application reads, right? So for this user over here, the primary writing will always happen to master. Okay, it will not write to your read replica. Okay, however, the primary server for reading will always be your read replica. right? So you have to basically set it up like that. Your application will be using two different endpoints, one endpoint for writing and one endpoint for reading, right? So the primary will be the local one, not the one on the other side.
Thank you. So he's has another question. So currently, AWS migration is in planning the project, and in terms of performance and cost, which database would you suggest? This is more of a customized question.
Yeah, it is a customized question, and if Rizwan, if you don't mind, I'll probably answer that towards the end. So Srika, just keep that question in mind. Towards the end, I'll probably ask that because that requires a little bit of
Sure,
explanation. And sure.
sure. Thank you.
Yep. Thank you for the question, though. All right. So moving forward, let's talk about automated backups. So RDS actually offers you the option to create backups. Now, of course, you can manually take backups, but you also have the option of automating the backups. The backups that are normally available under RDS is once in a day scheduled backup of the entire instance. These backups are retained for about 35 days, and when normally these backups happen, it happens from a standby if you're running in multi-AZ mode. If you're running in a single AZ mode, obviously it is going to only happen from your master, which basically means it might affect the performance. But if you have a multi-AZ setup, it'll always take the backup from the standby so that your main database is not affected. Now, when you talk about Aurora, the backup is a little bit different in the sense that it is not like a once in a day backup. Because under normal MySQL, Postgres, MariaDB, Oracle, and SQL Server, when you talk about backups, RDS backups, you're talking about a single once in a day backup, right? So, for example, if you set a backup at 2 a.m., it does a backup every day at 2 a.m., right? But when you talk about Aurora, it's a little bit different in the sense that it's automatically backed up. It is a continuous backup and it's an incremental backup, which means literally every few minutes, it's continuously backing up your database. And there's absolutely no impact on database performance. And you have the option of something called rewind and forward. And this is offered through a service called Backtrack. What this means is you can go back to any point in time, right? So under normal RDS, if you had to go to a backup, you had to go to like previous day's 2 o'clock backup or the day before that 2 o'clock backup or something like that, right? But when you talk about the rewind function here in Aurora, you can literally go to 5 minutes ago, or you can go to 30 minutes ago, or you can go to 1 hour ago. And let's say you made some changes and you realize that 2 hours down the line that those changes were, not what you needed. You can go back 1 hour, and let's say after going back 1 hour you realize that okay, this is fine, but then I made some changes a little bit later and I don't want that. So you could, from that point, you could go 30 minutes forward, right? So you came back 1 hour and then you could go forward 30 minutes. So essentially from the original time you went back only 30 minutes, right? So you have this option of going back and forward in terms of restoring your data when you talk about Aurora, right? And this also has a 35-day retention period.
This is awesome.
Yep. All right. I believe this is the last option, which is the database migration service. And I think, Rizwana, when the question that you had about migration as well, you need to probably consider this option as well when you consider your migrations, right? So there is a service called DMS, or Database Migration Service. This kind of helps you migrate your database from wherever it is, okay? This you can use for migrating your database from on-prem to AWS. Or let's say you already have a database running on AWS and you want to migrate that into Aurora. You can use the DMS. Many other options. Even if you want to migrate your database outside, you can use the DMS service. Essentially, the DMS service is a service which lets you move data from one point to the other without any interruptions. How this happens is, in this particular example here, you see that there is an on-premises database and then there is the AWS side as well, right? And on the AWS side right now, as an example, we are using the Aurora database. And on your on-premises, let's say you have a MySQL database that you're running. you need to ensure that both the sites are connected, which means you either have a VPN connection or a direct connection running between your on-prem and AWS. Once all of that is confirmed, you can kind of start with a DMS service. Now, before you do this, obviously your users are connected to your existing on-premises database, as you can see in this picture. So how do you start? First of all, you go ahead and start the replication instance on the AWS side, which basically means you start the DMS or database migration replication instance. That's get started. And then you connect the source and the target database within the DMS application. So when you configure that, it connects to the source and the destination. In our case, the source here is the on-premises database, and our destination here is the Aurora database. So we want to migrate whatever is there on-premises into Aurora on AWS. So now we have connected the source and target using the DMS service. Post that, we will go ahead and select what all do we need to transfer. So from the on-premises database, we can actually select the tables, we can select the type of schemas that we need or the databases that we need to transfer. Once that is selected in DMS, it will initiate the transfer. Hold on. Once that is selected in DMS, it will initiate that transfer. DMS will basically create all of those tables. It will load the data and it will keep them in sync. So it will connect to both the on-prem and Aurora. And slowly, as you can see the data here, it will slowly start loading the database with all the data from your on-prem. And once it is completed, once all of the data has been migrated, post that, if you're making any changes on-prem, it will automatically copy those changes as well onto Aurora. So now it is like a continuous replication. After it makes that initial copy, it will continuously replicate the data. So it's not like once this is done that you have to immediately move or nothing like that. It will continue to replicate any changes that happen. And basically, once all of this is done, and now that you're sure that all of the migration has happened, you can basically go ahead and switch your applications from connecting to your on-prem to the Aurora database. So this is kind of how you can use DMS to migrate your data without any interruptions. Any questions? I don't see any. All right, I'll
no questions.
move forward. All right, let me do a quick demo and show you how this works. Okay, so right now you can see that I kind of already have a demo database running, but if not, essentially what you have to do is you have to go into RDS once you're logged into the console. And inside RDS, you will go to databases and you will click on create database. Now, before you do this, there is one important thing that you have to kind of keep in mind is you need to have a subnet group created. Subnet group basically refers to this one. So essentially, if you are doing a multi-AZ, so AWS kind of assumes that at some point in time you will use the multi-AZ. So before you create a database, you have to select two subnets that you're going to be configuring the database in, right? So you have to select pre-hand which are the subnets that you're going to use for your databases. So I'll just move back here. So you have to create a subnet group first. Once that is done, you just go to databases and you click on create database. There is a wizard type which you can use with easy create, but I'll just show you the standard create. As you can see here, you have multiple options. You can create an Aurora database, or you can do the standard RDS, which is MySQL, MariaDB, Postgres, Oracle, and SQL Server. So if I select MySQL, I can select the database version of MySQL that I need. I can select whether it's in production, whether it is dev test or free tier. Production is essentially assuming that you're going to use a multi-AZ setup, right? So it's not going to be a single AZ. It's going to be a multi-AZ setup. Oops. Yeah, so if you select production, it's going to be a multi-AZ setup. Right now, I'll just show you the dev test part. You have to give a name for identifying the database in the console. Now, this is not your database name. This is for identifying the server that you're creating. All right. Then, of course, the username, the password, and then you have to select the size of your database here. If you're just starting out, you can do burstable class and then select one of these smaller servers. But ideally speaking, you would either go with memory optimized or standard, which is M6 type of servers. So once you select that, you can select how much disk capacity do you need. Minimum is always 20 gigs. You can do auto scaling. You can do auto scaling if you want, in the sense storage auto scaling. This is not scaling your server. This is just scaling your storage. So if you hit 20, you want to auto scale it up to 1000, you can do that. So it'll automatically keep increasing the size of your disk without you having to manually do it. As we can see here, multi-AZ right now is selected to do not create because of the fact that we have selected a dev test. But if we select production, you should see here now I have the option to create a standby instance, which is obviously recommended for production. But at this point, I just do without a standby. You have to select which VPC it is going to be in. You have to select the subnet group. This is what I told you that we need it prior before we create the database. We need to create the subnet group, and we have to select that over here. Public access will always be no. Unless you're testing something and you need to directly access the database, you can select yes. But for now, we'll leave it to no. You have to select security groups that you're going to use the database under. Here you have the availability zone. Which availability zone do you want to place your primary in? The secondary, if you have multi-AZ, obviously if you select primary as 1A, it will place the secondary in 1B or 1C. Then if you want to give the database name, of course, you have the port number, password authentication. If you're using IAM authentication, you can select this, but then normal authentication is password authentication. Additional configuration is where you will specify your database name. Here's where you'll select what is the name of your database. Here is where you will select your automatic backups. So remember, I told you it has a maximum of 35 days of retention for your backups. This is once a day backup. And how do you select the time period here? You can select a window here, and you can select the time period that this backup will take place. And then you have the option of encrypting your database. You have the option of enabling additional performance insights, which is to get more information about the database performance. You can enable monitoring. You can enable logs. Here is where I said if you select auto minor version upgrade, if your database is, for example, 5.6.2, and there is a new update for 5.6.3, it will automatically do that. You don't have to spend time doing it manually. Enable deletion protection is important if you don't want to accidentally delete your database. And once all that is done, you have the option over here which shows you what is the total cost for running the database. This is an estimated, it's not 100% accurate. This will change depending on how much you access it and all of those, how many times you're taking a backup. It'll change based on that. And then all you do is finally kind of hit create database option. Now, I'm not hitting this right now because I've already created a demo database here. As you can see, once you do that, it creates a demo database here, and this was created in AP South 1A with a DB t3.micro. All right, I think there are a few questions I'll take.
Yes, so the first question is from Volnik Asar. So he asked that how to secure the database while doing the migration. Yeah, that's the question.
Right. So first thing to understand here is that you are not changing any existing security parameters for your database. All right. What you're essentially doing is you're only allowing an additional connection to come into your database, which is basically the DMS. Okay. So when you configure DMS, you will get it will tell you what is the IP address of the DMS that is going to connect to your existing on-premises server, right? So essentially you are just opening that one IP for your database. However, remember, this is not coming over the internet, because if I go back to that slide here, remember I told you that there is already a secure connectivity in terms of VPN or direct connect between your on-prem and AWS. So the connection is already secure between both ends. It's not, there is no internet in between. It's kind of, I mean, there is internet in between, but it's a private connectivity already happening. All of the data is already encrypted as it is traveling across, right? So it's secure in that way. And of course, on your on-premises side, any firewalls that you have, you basically have to open a port for DMS to connect in so that it can fetch the data. I hope that answers it. What is the second question?
So the second question is, can you please explain difference between database name and database identifier?
All right. So the database identifier is this one here. So let's say I have created 10 different databases. Now remember, when you create something called a database in RDS, what you're creating is a database server. You're not creating a database inside a server, you're creating a database server. So you might have multiple servers, which again have multiple databases inside them. The identifier is the name for the server. So here you see this is the server name. So when I created the identifier as demo database, this was basically the server name. Inside this database identifier, I can create multiple databases on this particular server, right? So essentially, let me show you the name here. When I created the database with server name as demo database, where is the DB name? See, the DB name I created was just demo. All right. So this is a server name and this is a database name inside that server name. So instance ID or identifier is a server name. So I can have multiple servers here, which will show up in a list over here. Each of them can have multiple databases with which obviously is the actual database name. I hope
it's like a host name of your database server.
Right.
More or less.
And just to quickly show you this, I just wanted to also kind of show this, just one quick second. I'm basically just creating a rule inside of, yeah, I think that's already created. So what I'll do is, okay, I'm actually using a tool to connect to the database from my desktop. Now, remember, I had created this as publicly accessible as yes, which is why I'm able to do this. If I had selected publicly accessible as no, I would not be able to do this. So just keep that in mind. Okay. I think that should be it. Yep. So if you see here is that database name demo. So I am currently logged into the server and this is the database name. And of course here, if I want, I can create multiple databases, right? I can go ahead and create multiple databases over here, create new database. So the actual identifier is the database server host name and the DB name is the actual database name. I hope that helps.
Thank you for the clarification, Faisal. So we had one question from Rizwana. So it is about, it's a personalized question where he said, in terms of performance and cost, which database would be like the perfect fit?
Okay, so standard use cases, if you're talking about cost, MySQL is what you would normally go with, right? Now, again, I don't have all of the information about what your company is doing, so I can't give you 100% correct answer. But generally speaking, if you have decided to go SQL way, remember we first discussed NoSQL versus SQL, right? So if you decided to go the SQL way, you would be better off with just using MySQL as a starting point because it is open source. MySQL or MariaDB basically. So it is open source and you can basically use it for free almost. Of course, you can pay certain companies to implement it for you. You can get support from certain companies. If you don't want but remember, if you do that, then you have to either run your own server on AWS or run it as RDS, which kind of rules out the possibility of you having to maintain the server. Or if you don't want to maintain any server and you just want it done, then you can go with Aurora, right? Aurora MySQL, which will where you're only worrying about the data, you're not worrying about the underlying server, so you don't have to worry about managing the server itself. So a lot of overhead that you might have to consider is gone. Then you're only worrying about the cost of actual running Aurora. But be careful, it can get expensive. So if you want to keep your costs down while at the same time selecting a good type of database, then just go with a regular MySQL or MariaDB. Run it on your own EC2 instances or on RDS as well. I hope that answers.
Thank you, Faizal.
All right, with that, I'd like to wrap up, and I want to thank anyone for listening in. And if there are any questions, we can take them, and I'll hand it over to you, Srika.
Thank you, Faizal. Thank you so much for that detailed explanation. And I think we have another question. Let's take that. It's from Crapmel Tone again, and this should be a question to ask at the end of the session. Are you planning any other AWS sessions for compute or network? Yes. So we are having some sessions lined up. Please follow us on our uh, LinkedIn, Twitter, and Meetup pages. Please register or become the member of the Meetup group so that you can be informed. We have many sessions coming up in the next few months, so please do watch out for more information. And thank you so much, Faisal, for taking time. And the explanation was very clear. It was very detailed as well. And sorry for the mishaps in the middle sometimes. But yeah, I
That's
think
perfectly
our
fine. That's all right.
users have got a good understanding or solid understanding of AWS databases. So before we wrap up, we want you to provide us a feedback. So if you see the YouTube, since now you're using the YouTube to check this streaming, if you go down, you'll have the link for the feedback. Please do take some time to fill the feedback form so that it will help us for our future sessions, and also it will help Faisal for all his future talks. And with that, okay, so can you take up sessions on AWS security? Yes, we have some sessions coming up, and there are other user groups also who are conducting sessions on AWS security. You might want to follow AWS user group India so that you get all these kind of news on that. So
Srikar,
we
can
are
I
already.
make a quick pitch for one of the talks coming up?
Yes, please. Yes, please.
Yeah. So just for anyone listening in, I will be doing a session next week under the AWS Hyderabad user group that will be regarding the IoT side. So if anyone is looking for IoT sessions, please follow the Hyderabad user group and you will get the updates. But I believe Srikar will be posting more meetups from the Vizag group, which is
Yep.
probably coming up. So I think for you to consider, Srikar, is probably the compute, network, and security, right?
Sure. Yep. Yep. All right. Thank you so much, Faisal, and thank you everyone for attending our live session. So we'll be ending the live in just few minutes. You are open to leave the broadcast, and please do not forget to go and give your valuable feedback. Thank you.
Thank you, Srikar.